Hey, fourth graders. This is pages 271 to 272. It's just a review, so nothing new. Alright, so I just want to go over each problem, show you how to do them. First one, give the common name for each shape. So you just look at the picture of the shape, write down the name of the shape. If you go back to page 269, you would see the names of these shapes. Something I want to go over really quickly is that I didn't do a good job, I think, of telling you the difference between a rhombus and a parallelogram. Okay, so let me draw a rhombus here real quick. Or this is a parallelogram, sorry. So parallelogram. And this is my rhombus. Okay, I'm going to change this parallelogram a little bit. Okay, so this is a rhombus. Alright, so if you recall, a parallelogram, the opposite sides are parallel. Okay, so that means this side and this side, they're opposite, right? They're across from each other. They are parallel, meaning if I extend these lines, they would never ever cross each other, okay? Yeah. Same thing for the other sides too, top and the bottom. If I extend these these sides, these lines will never crash into each other, right? Yeah. So that's what makes this parallelogram. If you see here in parallelograms, it doesn't matter the length of the sides, okay? So this could be the sides could be 4 inches and the top could be 7 inches. It'll still be considered a parallelogram. So yeah. But in the rhombus, the big difference in rhombus is that the sides are still parallel. So opposite sides are still parallel. These lines will never cross if I extended them. Same thing for the top and the bottom. Okay, if I extend these lines, they will never crash into each other. But the big difference in the rhombus is that all the sides have to be equal. Sorry. So all the sides have to be the same length. So if one side is 5 inches, then the other sides also need to be 5 inches in order for it to be a rhombus. All right. So that's the big difference. In the rhombus, it's a parallelogram, but with all equal sides, and then parallelogram is just that the sides are just parallel. Opposite sides are parallel to each other. All right. Hopefully I didn't confuse you too much. All right. So same thing for number 2, matched by drawing lines. Let's see. If you go back to page 267, that's going to help you with this page here. Number 3, write the correct temperature in the blank. If you look here, the temperatures, it goes from 15 to 25. So it's going by what? 2s, 5s, 10s, let's see. So let's see if it's going by 5s. If it's going by 5s, then 15, this would be 20. Next one would be 25. So definitely not 5s. So what do you think? Probably 2s, right? So this would be 17 degrees Celsius. The next one would be 19 degrees Celsius. 21 degrees Celsius, and then it's 23. Yeah. So it's going by 2s. So it's asking you, what's this temperature if it's between 21 and 23 degrees Celsius? Okay? Make sure you write down the correct temperature. It switches from degrees and degrees Fahrenheit, all right? Make sure you label your temperature correctly. Number 4, see, Mr. Cal spent $18.97 on flowers for his wife. He gave the florist a $20 bill. What coins and bills did he receive as change? All right, so figure out what the change is. Figure out what kind of coins. Remember to use the least amount of coins. And what are the bills that he got back? The candles was 10 inches long when new. Each half hour, 3/4 inch of the candle burned away. After 4 hours, how long was the candle? All right, so if you know that for every half hour, 3/4 inches gets burned away. So after 4 hours, you got to figure out how many inches is that and subtract that from how long the candle was before when it was new. Okay, let's go to the next page. All right, just write down the Roman numerals for each one. Page 349 in the back of your math book will help you with this part. Okay, divide and check. We've done these before. Circle the hottest temperature in each row. So for this one, let's go over it real quick. Let me do an example question here. Let me choose a darker color. So let's say this was my temperature here. All right, so remember, in America, we use Fahrenheit, okay? Fahrenheit is what we mostly use. All right, so do you remember how to change Celsius to Fahrenheit? I went over it really quickly in one of the videos. In order to change something from Celsius to Fahrenheit, really easy. Just take your Celsius temperature, times it by 2, then add 30. So for example, for my 3 degrees Celsius, I would take 3 degrees times 2 plus 30, which gives me about, so 3 times 2 is 6, plus 30, 36. So this is 36 degrees Fahrenheit, okay? So change them all to Fahrenheit. Same thing with this one. All right, so 29 degrees Celsius, change that to Fahrenheit. I would need to 29 degrees times 2 plus 30. This would give me, so 29 times 2 is about 58, plus 30 would be 88, so that's 88 degrees Fahrenheit. Okay, so which one's bigger? 36 degrees, or which one's what's the hottest temperature? 36 degrees Fahrenheit, 21 degrees Fahrenheit, 88 degrees Fahrenheit, or 25 degrees Fahrenheit. Of course, the biggest number, right? This one right here. So this would be my hottest temperature. So do the same thing here. Change all these Celsius degrees to Fahrenheit to help you compare easier. Okay, circle the largest measure in each row. If you go back in your book, let's see here, we have page 348 will help you with this problem here. Or let's go back to my lesson on the metric system on liquids. All right, everything here, pretty much everything we've done before. And yeah, all right, so that's pretty much it. Okay, take care.